Well, welcome to the presentation. Like what Matteo said, we're going to talk about ASCE 38 and ASCE 75. Being that I have a half an hour, we're going to basically be flying at about 5,000 feet on a lot of this. We're going to go through a quick overview of everything. But let me introduce myself. My name is Tom Pilarski. I am the Vice President and Director of Subsurface Utility Engineering with Psomas. We are a survey, engineering, environmental, and construction management firm in the Western United States. And I head up all of our subsurface utility engineering needs here at Psomas. So with that, an overview of what we're going to go through. We're going to talk a little bit about why ASCE standard 38 and 75 are important to your design procedures. We're going to give an overview of 3802 because it's the base. It's where we started, like Matteo said, 20 years ago. We're going to talk a little bit about how we got to 3802. Then we're going to talk about the updates in standard 38 that were in 3822 and the introduction of standard 75, which is the mapping standard. Why are we going to do this? What are our objectives when we get to the end here? The importance of proper utility research, locating, and mapping. I think we've all seen how with improper mapping standards, with improper locating, what's happened. You know, we've had a lot of utility strikes as of late. We've had a lot of utility failures and whatnot. So we're going to talk a little bit about the importance of it. And we're also going to look at the importance of utilizing the guidelines set out in ASCE 38 and 75. And I want to stress that these are guidelines. They're not rules. There is a lot of flexibility within it. Each of our companies and like the agencies, you know, how we interpret this and how we use this is up to the professional. So with that, why are ASCE standards 38 and 75 important to your design procedures? So I had the opportunity, probably now going on about 10, maybe 15 years ago, working with Southern California Gas Company and San Diego Gas and Electric on their pipeline safety enhancement program. And this is where I kind of saw the importance of this ASCE standard and how to implement it. When we first started the project, we were using kind of one call to do a lot of our utility marking. And as you can see here from the pictures, you know, it would go out and mark it, and then we'd go out and dig. And like this first picture shows, we struck a water line because they improperly marked where the line was. It got a little worse as we went through the project. We had a couple of bad explosions because we even used some of the SoCal Gas and San Diego Gas and Electric. We used their utility locators, and because they were improperly trained and didn't fully understand the importance of how to properly detect this stuff, and somewhat the improper use of their records and their data management, we had a couple of pretty bad explosions during our project. One there on the bottom left, it took that tractor and it pushed it straight up into the air a good 5-6 feet. When he struck a gas line because the gas line was improperly marked. So, you know, this is the reason why we have these standard 38 and 75 is so that things like this are minimized. And I want to stress minimized because even with as good as we are, this is risk management. This is safety management. It's not a foolproof thing. So why should we incorporate these standards into our design procedures? Buried infrastructure has become more congested. A lot of times when we're going down the streets, you know, we're putting in more and more utilities as time goes on, but we're not taking out the old ones. We're not taking out the abandoned utilities or older utilities. We continue to add, update, and relocate subsurface utilities because of mission changes, expansion, modernization, and public demand. I mean, we've seen this now with broadband and such. You know, we continue to add in things into the street, and it continues to congest the area. Rarely do out of service utilities get removed. This is an important one because sometimes when they get removed from the as-built plans and they get removed from records, but they're still on the street. So how do we go about identifying those? Complete, up-to-date, dependable, and accurate records of underground utilities are rare. We're finding that now, as we take a look at the past, that finding good as-builts, finding any as-builts can be a challenge in doing your project. Designing around utility conflicts is getting tougher and tougher because of the things that we just got done citing. when you have a road full of congested, it's fully congested with utilities, it can be hard to find a corridor where to put things. Or when you're doing a design project, the challenges of doing your project around these meters, these valves, and these boxes that are in your way, and faults and others, can create challenges when you're doing your design. So let's take a look at the standards. We're going to start with the base. We're going to start with the base 3802 and why we got to 3802, the importance of it, and how did we get here. So prior to 3802, what did we do? So use of records to guide locations for test holes. Test holes were basically, the big thing. If we're going to find a utility, man, we're going to punch the ground, we're going to go down, and we're going to look for it. Well, the problem with that is that sometimes records were never made. The records were incomplete and incorrect. Sites are repurposed, abandoned, hard to find positional references. You look at a map, if you have one, and you're trying to figure out, okay, what is this relational to? Is it relational to the curb? Is it relational to the center line? Is it the stripes in the road? What am I looking at, and how am I getting myself positioned here in the street, in the right of way, or even in a parcel? Some of the records were lost. Whether here in California, we had a big fire in the 1910s and the 1920s that just took out records. So we lost a lot of our records here in Los Angeles because of that. What did this result in? Holes with no data, or data where there are no holes. Because we're punching holes in the ground trying to find the utilities, we'd have just holes that are just there, and they were of no use, but you spent all that money punching a hole in the ground. So it just was like, okay, there's got to be a better way of doing this. So we went to this use of one call to guide the locations of test holes. And I know in many states there's a design ticket. You can put in a design ticket, and they'll go out, and Blue Stake or some other one call company will go out and they'll mark the area for you. Well, the problem with that is it's too late to consider planning and designing uncertainty in your management. The other problem is that it only marks some utilities, because you have to be a partner with the one call system, and you have to be part of that system in order for your as-builts to get used, and in order for you to be a part of that one call ticket. A lot of times the people who go out and locate for the one call system, they're poorly equipped. A lot of them only have an electromagnetic device. They don't even use GPR or other types of equipment when they're out there. They're also poorly trained. I know some of the guys that I've seen, they treat the wand of the EM, kind of like it's a pendulum, swinging it back and forth, in a method that's not going to accurately locate the utilities. Plus, they're poorly motivated. And this is somewhat a part of the system when they're being paid by ticket. And now all of a sudden they have like 200 tickets to get done in a day. And I'm somewhat exaggerating here, but when they have a lot of tickets to get done into the day, and they're driven by getting tickets done as opposed to properly locating utilities and being more accurate. Another problem with this is there's zero responsibility for design issues. Once they've marked the ground, they walk away, and hey, good luck. They have zero responsibility for accuracy if it's a design ticket. These are problems with the one call system. If you're going to rely on them, understand that once they mark it, they walk away. It doesn't matter how accurate it was or anything else that has to do with that marking. And it's interesting to note that in 2010, the Virginia Department of Transportation, they did a study, and it showed significant errors and omissions when one call marks were done during a project. They weren't, and it had nothing to do with how the survey was done, because the survey can go out there and accurately locate the paint marks. It's how the utility detection work was done in the field. And there were significant errors once we got into construction. So ASCE standard 38 benefits. And this is really important to understand. because ASCE 38, Standard 38 was created to save time and money. And what the objective was to enhance safety, reduce unexpected conflicts with utilities, and then avoid unnecessary alignment changes. By understanding how to properly map, research, and detect the utilities, the feeling was that we would have a better project. And by the time we got to construction, you would have less RFIs, you would have less change orders, less back charges. So what did ASCE 38 establish? So the first one established the mapping of utilities early in a project. They tried to push as much as possible the mapping of the utilities to the design phase. It used to be like when I first got into land surveying, a lot of the utilities were done once you got into construction. You had to pothole before you started excavation. You had to do a lot of work in the construction phase so that you wouldn't strike anything. Well, what ASCE 38 tried to do is try to front load that, try to get it to the mapping side so that by the time you got to construction, you had a proper understanding of the site that you were working in. It also created definitions so that we have a common language. This was very important at the time. By creating the risk levels of quality level A, B, C, and D, now we can understand what we're looking at when we look at a design. When we see a quality level A, we know that that's a positive location of a utility. When we see B, we understand that it's utility detection. When we say C, we know it's surface visible evidence is probably located by survey methods. And D, we understand that that is by utility research. It also gave us information, showed us how utility information can be attained. It was about going out, getting as-built. It's about going out and detecting utilities. It was about how we could obtain the information we needed in order to have a good design. It created a risk-based process and a visualization. And like we talked about the quality levels, A, B, C, and D. Each one of those quality levels has a level of risk assigned to it. Quality level D being the most risk, and quality level A showing the least risk because you had a positive location of that utility. What technology is available? It showed us about GPR. It talked about EM. It talked about all the different types of technologies that are out there in order to assist in proper locating, mapping of utilities. How to interpret the data from those technologies. How are we supposed to look at it? How do we assess the risk when we're using each of those technologies? Only dig test holes were necessary. It talked about intelligently doing test holes. When I first got into surveying, man, we would turn a street into Swiss cheese because we were about potholing everything. Well, when ASCE Standard 38 came in, it said, well, why are you potholing sewers and storm drains when you can obtain that elevation data by dipping a manhole? Why are you doing test holes outside of your design corridor when you don't need to understand positively where those are? Make your test holes in your design corridor. Make it more smart about how you're going in test holing so that you're not using this intrusive method just to go ahead and to find out all the accurate elevations for things, even if they're outside of your design area. It helped with keeping an accurate utility composite database for future projects, maintenance and operational support. So it was the first one that came in and said, hey, it's not about locating all this stuff. It's about creating a database. We're talking about how bad the old as-builts are. We're talking about how bad the system is up till now. Well, if we're going to move forward and we're going to have a better system in the future, let's show how we can accurately create a database of the utilities that we're locating and all of this data that we're now compiling. How do we positively use it as we move into the future? So we talked a little bit about the quality levels. Here's basically how this process was developed. And I want to point out that this process was developed by the Federal Highways Administration, prior to ASCE Standard 38 and in conjunction with ASCE. So if we take a look at the quality level A, that's your vacuum excavation. That's when you take your test holer out there, he goes out, he punches a hole in the ground, He actually physically sees the utility. So you're looking at it, you have the utility, you can see the pipe size, you can see what the material of the pipe, you're actually seeing it right there. Now it's important to understand that quality level A is only good for that position that you're locating it at. The rest of it, if you did utility detection, which is the next quality level, the rest of it's still quality level B. And you as a design professional have to decide what level of risk are you going to assign to the utilities that you're mapping. When you look at this, it's all about you and what you feel comfortable with. So you have a positive location in quality level A. You have the geophysical information, which is use of GPR, electromagnetic. You have the magnetic devices. You have sonic. So you have all these different devices that can give you a location, but still, it's not as accurate as looking at it. You still have some error introduced by these pieces of equipment. You also have site assessment. This is usually done by the survey team when they go out to do their topographical mapping. They're seeing meters, they're seeing valves, they're seeing vaults, and they're seeing things that show where the utilities are, but yet we still don't understand where they are underground. So it gets a little bit more risk because we see the evidence of a utility, but we still don't understand where it is underground. Then you have quality level D, which is your historical records. This is your as-built. This is your information when you talk to, say, the older gentleman that was there that put the water line in, that works for the water company, and he looks at it and he goes, yeah, those as-built are wrong. When we put it in, we found an easier corridor and we put it over here. So that type of verbal evidence would go in as quality level D. So this is the greatest benefit when it's used prior to the design phase of construction projects. But, I want to emphasize that it's never too late to use it. So implementation objectives of ASCE 38. We want to establish a common terminology, and it basically did do that. It enhanced communication. It started to get the surveyor to talk to the design team to talk to people in construction. It started to create this cohesive communication as the project moved through 30, 60, 90 and into construction. It also created a partner with the test hole company. Now, instead of just giving the potholer or the test holer, this plan and saying, go out and, punch all these holes in the ground, now you're partnering with them for a smarter plan. It applies lessons learned. You're looking back at previous projects and you're going, what did we do right? What did we do wrong? And how do I use that in my future projects? And then also managing risks, because at the end of the day, that's what this is all about. It's not about removing risk, it's about managing the risk. So 22, the update. What did we do in 22 that's different from 02? So in 22, we updated our definitions. We started to enhance them to bring them into what technologies we have now and how are we moving forward, because from 02 to 22, a lot happened within our industry technologically. Designating precision. We now can locate things in a much more precise manner, and we can also start to take a look at how do we define the different risk levels from a precision standpoint, and then what's the proper way of assessing those risks. It also talks about measuring, documenting, and depicting of vaults. I know that in the past, we used to locate the manhole or the entry point of a vault on top, and we would call that, it's a vault. Well, sometimes when you pop that open and you look underneath, that vault is much bigger than the opening that it is. And sometimes that vault opening is offset and it's not exactly in the center. So a lot of times you have utility conflicts in construction, or you have construction conflicts because the depiction of that vault isn't accurate. So with this, one of the updates is address the depicting of the vault so that the design engineer has a better understanding of where that vault is. It also talks about depths and 3D models, because now we're at a point where we can 3D model the under the street like we do when we're in buildings and we're doing the 3D model above. We can do pipe conflict, and we can use different methods within our CAD structure to take a look at utilities and where we have possible potential risk or potential conflicts. And then also it talks about the data necessary for a utility report. The utility report to me, was one of the more important things that came out of 22, because it established something that the design professional could use as they started to move forward in their design. And I'll talk a little bit more about that as we move forward. So here's the report that we're talking about. It accompanies a graphical deliverable if the necessary data is not able to be incorporated fully into the notes and plan sheets. And basically, what this is intended to do is it's intended to show what happened in the field. What did the utility locator run into? Why did he lose signal? Where did he lose signal? Because if you look at the way things were done prior to this, you could have a utility detection crew go out there and they're detecting utilities and then they lose signal and then they pick it up a few feet later and then they lose signal again. Well, all of this is intended to show what's going on, what happened in the field. It's much like a surveyor's field notes, but this is giving the design engineer the ability to understand what the locator is locating, how did he locate it, what are the methods that he used to locate it, and then what did he see and understand in the field. The preparation of utility report contains information about the utility investigation that may not otherwise be conveyed. It will assist the end user in better understanding the subsurface utility landscape and risks, and will complement the utility mapping deliverable. It's important to understand too that this report is to help the engineer assign risk, because we can go out there and detect something, and if it's very spotty in the way that we detect it, the professional engineer might look at it and go, yeah, I'm just not feeling comfortable calling that quality level B. I think I'm going to bump it back to quality level C. And therefore, you're assigning a little more risk to it. We're giving the design professional the information they need to not just flatly call it quality level B. Understand the accuracies that are being established by the locator in the field. How comfortable was the locator in locating things? How did he see what he's seeing? The utility report should be sealed and provided to the project owner in electronic or paper format, and within the database or a 3D model. It should contain the following, but not necessarily all inclusive. So it's important to understand that it should have the project description, project limits, type of work, existing utilities, give an overview of the area that you're doing and why you're doing this. Contract requirements relative to the utilities. Why are you being put out there? What is the end game of the utility detection crew? What are they doing? The methods used to collect and depict the subsurface information. Did you use a GPR unit? Did you use an EM locator? Did you use the sonic wave? Did you use a magnetic locator? State what it is that was used so that everybody is on the same page. As did you use a Sensors and Software's LMX 100? Did you use a Leica? What piece of equipment did you use and what accuracy? What method did you use when collecting it? So that when the engineer goes to depict those utilities, he has a better understanding of what you did, how you used it, and they can be able to assign risk. The type of equipment selected to use the information, also types of software used to depict the information. There's a lot of software out there within the equipment and then within the post-processing in order to develop the report. What areas did you sweep? Areas not swept? Suspect areas, where do you see challenges? What utilities did you locate and what is depicted? What type, what attributes? All of this can be defined within the report itself. Successful outcomes, how many feet were designated, number of test holes excavated. All of this should be contained within that report. Problems encountered and resolutions, unidentified utilities, thoughts of not being able to get signal from two different instruments. This gives the opportunity for that detection crew to be able to say, hey, here's what we saw, here's what we think, and then giving more information to the professional engineer so that they can assign the risk. So ASCE 38 for vaults. It states that we should be measuring from a fixed point, usually the center of the lid. Measure to all four sides and the bottom. Give a good detection, a good mapping of what that vault looks like so that the design professional can understand what exactly they're looking at. Understand that the GPR will not give you a bottom elevation. Here's a depiction of a vault diagram that we use. And you can see what the inside of the vault looks like. You can see the width, you can see the length, you can see the depth, you can see what's contained within it. And by doing something like this, you're giving the design professional understanding what exactly is going on inside that vault so they can design around it. Another update to ASCE 38 is depths on mapping deliverables. Making sure that we're identifying the depths of the utilities as the locators are identifying them in the field. Now, not all utilities we're able to obtain depths, but on the ones we are, and we give that information to the design professional, we should be putting those on the maps so that is conveyed as we go down into construction. So this update also contains all work is performed under the responsible charge of a registered professional. This was an important update to it, making sure that we understand that a registered professional should be overseeing this work. Because you have a lot of these little companies off and going on their own. ASCE wanted to make sure that a design professional is overseeing the work being done and that they're not off on their own doing this work. Test holes or exposures without designating and records research cannot ever be called QLA. Just because you're punching holes in the ground doesn't mean that you get to call it QLA. If you haven't followed the proper procedures by going from D to C to B to A, you shouldn't be calling it A. Remember, this is risk management. And by not following all the proper procedures, can you really get to that highest level of risk management? Survey of a marking done by someone else, a one-call mark or design ticket can never lead to a QLB detection. If you or someone that you hire did not do that utility detection, you should be calling that a higher level of risk because you don't know exactly the methods they used. You don't know how they went about locating it. ASCE 38 is for the benefit of design. It is not the replacement of damage prevention during construction. Understand that ASCE 38 is for before construction. Understand that this is to assist the design professional in putting together what they're doing. ASCE 38 is a blend of knowledge of geophysics, survey of fixed objects, earth, utility design and construction, and engineering uncertainty. It may require a team. In fact, I would say it does require a team under the direction of a PE or a PLS. QLB cannot be accomplished without the consideration of a wide range of time domain, frequency domain, magnetic GPR, and elastic wave methods that are applicable to the project risk and anticipated known and unknown utilities. All the different types of equipment should be used if you're going to establish a proper QLB designation. So here's the validation, and I'm going to kind of speed up a bit so that I don't put us behind. Validation of SUE practice. By understanding ASCE 38, we have a $4.62 saving for every dollar spent on SUE. That is the main reason why we try to push out ASCE 38 because of that savings once you get to construction. So ASCE standard 75. 75 is a complement to 38. It's not a replacement of 38. It's not intended to. It's kind of the mapping portion of what's being done in 38. What this does is it establishes the essential elements for recording and exchanging of utility data in regards to the location of the utility. It's about the positional accuracy. It's about collection intervals based on alignments. Rob's going to talk a little bit about this in his presentation, but AS 75 is much more about the positional accuracy of what we're doing. It's about the size of the utility, the orientation of the utility, the function of the utility, and the ownership of the utility. How do we map all of this? How do we record it? About recommendations for effective data exchange practices. It's also meant to facilitate the interaction on the management of the utility data. So the benefits of ASCE 75, effective utility data exchange among stakeholders. Consistency with and support for current and emerging digital project design. This is bringing us into the current area where we're trying to use CIM, BIM, VDC, a lot of the things that Matteo talked about in his opening remarks. It's also enhanced damage prevention, including real-time augmented reality visualization. There's a lot of stuff out there where we give the ability to the construction folks where they can put on some VR goggles and they can go out and they can see the utilities as they're moving through the project. Standardized recording and retrieval of utility infrastructure data. It's about asset management. It's about what are we doing with the data when we locate it? What are we doing with these plans and the utilities as we map them? It's more focused, effective utility investigation and conflict assessments. It's about the implementation and practices that are a result of resilient, sustainable infrastructure and more effective utility asset management. And with that, I will hand it back off to Matteo.